Welcome back, everybody. Today we're going to be going over our data analysis lesson on our light interaction experiment. So you can see that I've got the data table up on the screen right now. And I want to point out a few things. So in our experiment, our initial water temperature for group A, that's the group A that had the clear cup and the foil cup, was 1 degree Celsius. For group B, the initial water temperature was 3 degrees Celsius, and that's this group where we tested the black and the white cup. And then group C, the initial water temperature was 10 degrees Celsius, and that is the dark group where we covered up the cups with a black colored bin so they weren't exposed to any light. Okay, so what we're going to be doing is, first of all, taking a look at this data and trying to get a better understanding of what it tells us about each experiment. So in the Group A experiment, we compared the clear regular cup to the foil wrapped regular cup. And you can see after 15 minutes of time, the clear cup heated up to 8 degrees Celsius and the foil cup heated up to 4 degrees Celsius. So to really understand the difference that the 15-minute time made, we have to look at the change in temperature, and that's this column right here. So the clear cup warmed up, basically there was a change in temperature of 7 degrees Celsius. So quite a bit. Thinking about that, that means that some of that light must have been absorbed by the water. Probably quite a bit because that temperature went up quite a bit. If we look at the foil cup, the temperature only went up 4 degrees Celsius. So that means we have to think about, well, why didn't that cup heat up as much? So there's a couple possibilities. Did some of the light get blocked by the tin foil? It couldn't get into the cup. Maybe some of the light was reflected off the tin foil and bounced back, and that's why less heat was transferred. So you need to think about those things as we're analyzing the data. Okay. For the Group B experiment, we did the same experiment, but we tested the black cup and the white cup. So remember, our initial starting temperature was 3 degrees Celsius for Group B. After 15 minutes, the black cup heated up to 9 degrees Celsius, and the white cup heated up to 8 degrees Celsius. So we can see that for both of these, there was a change in temperature, almost 6 degrees for the black cup and 5 degrees for the white cup. You can see the black cup warmed up slightly more than the white cup. If we compare the colored cups to the clear cups, you can see that it is a little bit less. So the clear cup had 7 degrees, the black cup had 6, and the white cup had 5. Okay, so there definitely is an effect by using a painted cup, and it does change the amount of heat that's absorbed compared to a clear cup. Okay. The last group, and this was probably the most interesting group, this group was not exposed to light at all. Okay, so initially we took the temperature, it was 10 degrees Celsius. I did this experiment on a different day, and that's why the initial water temperature is different. It doesn't really matter, though, as long as we know what the change in temperature is. Okay. So after 15 minutes, our clear cup was 11, our foil cup was 11, and our black cup was 11. But look at the change in temperature. So it was only about 1 degree Celsius. So that's telling us there's a clear indication that light has a big impact on transferring heat and energy into our cup. And so that's something we have to think about when you're designing your cup thermos next week. What can you do to minimize that amount of light that will be able to get into the cup? All right, so in order to do our analysis, we're going to use this model to reflect on how we think light is interacting with the different cup systems. So the first thing that you need to do is you need to recognize, it says use drawings and words to explain how each cup surface affected how light warmed up the water differently. So what we're going to do is, on this first page, we are going to compare the clear plastic cup that got exposed to light to the clear plastic cup that was covered up by the black colored bin. So this cup did not get exposed to light, theoretically. So what we're going to do is we're going to use these symbols in our key, and we're going to draw these onto each model to show how we think the light impacted it. So your choices are, if you use a solid colored arrow, you would think that all the light is getting through the plastic and into the cup. If you use kind of a line dashed arrow, that means you think most of the light is transferring through to the cup. If you have a kind of short dashed arrow, kind of just short lines, then we'd say some of the light. Just use dots if you think a very small amount of light. And if you think that no light is getting absorbed, then you would just basically use dots with no arrow. Okay? So if we look at our clear plastic cup, if we think about the data, we saw that the temperature increased quite a bit. So you have to make a prediction. You're going to grab you can download this in Notability. You have to make a prediction about what you think is happening. So if you thought that all the light is getting through, you would draw an arrow like this, and you would assume that all the light from the sun or from the light in the room is going through that cup and being absorbed by the water. Okay? But maybe you think maybe some of it doesn't. Maybe some of it gets reflected. So maybe you think it's kind of like most light. Maybe you think that some of it gets through. So then you draw an arrow like this. And maybe you'd want to show that also maybe some of it bounces back. Okay? Maybe you think something a little bit different. So I'm going to erase this stuff. Maybe you think that only a little bit of light is getting through. Okay, so if that's the case, then what you would do is you would just use dots, and you put a little arrow at the back of it like that. And that would just show you understanding that you think maybe is just a small amount of light is getting through, and that the water is not heating up very much. So what you're going to do on each of these models is make a prediction of how much light do you think is getting through and how do you think it's absorbing. After you've drawn that out on both models, after you've shown what you think on this model and also this one where no light is theoretically getting through, then what you do is you come down here and you're going to answer this question. It says, how did you explain why the clear plastic cup in the dark was different from the other cups? So it's asking you to compare why was our data different for the clear plastic cup versus the clear plastic cup that wasn't exposed to any light. So you have a sentence frame to complete here. It says, I think the clear plastic cup absorbed heat and energy differently than the clear plastic cup in the dark because. So I want you to fill this in with what you think. And again, use what you put in your model about what you think about how much light actually transferred through the cup and into the cup and how that changed temperature to answer that question. All right, this is going to be our next model, and we're going to compare the black cup, the one that was painted black, to the cup that was painted white. And again, we're going to put in our ideas for how much light we think is transferring through. Okay, so with the black cup, since it's painted black, we noticed it warmed up a little bit more than the white cup. So I'm going to go with the solid arrow because I think maybe most of that light's being absorbed into the cup. With the white cup, because of the color, I have a theory that maybe most of the light's absorbed, but some of it is maybe reflected off because of the color. So I'm going to draw on what I think. Again, use that key. All right. And then it says, how did you explain how the water in the black painted cup warmed up compared to the water in the white painted cup? Well, for this scenario, if we looked at our data table, we noticed that, and I'm going to write it down here so you can see better. We noticed that the white cup heated up slightly less. So I'm going to say something like, I think less energy was absorbed by the white cup because it didn't heat up as much as the black colored cup. Okay, so I think the less energy, actually this would just be, I think, less. I think less energy was absorbed by the white cup because it didn't heat up as much as the black colored cup. So you're saying your explanation, you're saying what you think, and how do you explain the results? How can we explain that the black cup did heat up a little bit more than the white cup? So that's what you're doing here. You're finishing that sentence frame. All right, our last example is we're going to compare the cup that was wrapped in tin foil to all the other cups. So again, with this example, you want to show what you think about how much light was transferring through into the cup. So remember in the tinfoil cup, that one heated up a very small amount compared to the other ones. So I think I'll just use yellow this time because we're talking about light. I think just maybe a very small amount was absorbed, so I'm going to use my dots here and put my arrow like that. And I also think that because it's so shiny, kind of like a mirror, that maybe some of this energy, quite a bit of it, is getting reflected back. Okay, that makes sense. Maybe because like when you look at tinfoil, you can almost see like see yourself almost like a mirror sometimes, right? So maybe that means that light's being reflected back. But maybe you think something the opposite. Maybe because it's so shiny and bright, maybe you think that a lot of that heat's being absorbed, so you would show something like that. So it's up to you. You're making a prediction based off of what our data shows. So really look at your data table and think about what is that data table showing, and how could you best explain the results of our data. So if I look here, it says, how did you explain how the water in the foil-covered cup warmed up differently compared to the other cups? So again, here it says you'd fill in the sentence frame. I think the water in the foil-covered cup warmed up differently than all the other cups because. So you'd write your response here. So if I was doing this, based on our data, I think it's pretty clear that the tinfoil cup was absorbing less heat, okay? So if it says, I think the water in the foil-covered cup warmed up differently than all the other cups because the tin foil reflected and didn't absorb as much energy as the clear colored plastic cup. So I think the water in the foil covered cup warmed up differently than all the other cups because the tin foil reflected and didn't absorb as much energy as the clear colored plastic cup. So remember, what I'm looking for is you're gonna, in your model, show what you think about how much light is being transferred and absorbed. You don't need to show the water molecules or anything like that. I just want you to think about the light, and then finish the sentence frame. I'll be doing a Google Meet lesson on this today as well, so make sure you tune in at 1 p.m. So that we can go through this together and work through this together if you need some extra help. If you have questions, send me a message in Schoology, and have a great day.